I'm Aaron Patula, developer, a Java and JavaScript developer at Elevon, and I'm going to be talking about um, the coding interview. There we are, okay. Coding interview for the anxious based on my experiences with interviews. So imagine you're getting ready for a coding interview and you're in front of your computer on the weekend and everything's really comfortable. You're just doing some code. You remember everything. You research some more advanced algorithms and everything looks good. So you go in for your interview and they ask you something that throws you a bit and you can't remember something right away. So you get a little bit of anxiety there and you get a little bit of anxiety there, and you start having more difficulty remembering things, and you have a negative feedback cycle, and things sort of get worse and worse. It can get to the point where you actually can't remember basic facts, or you can barely reason through the logic of the problem. So the reason why that happens is that attention is a limited resource, and what explains this is the software agent model of cognition. There it is. So the idea is that your short-term memory is a kind of workspace, and you can only consider so many things at the same time, and there's only so much space and so much processing you can do within this limited workspace. And so an implication of this model is that new situations and stress, new situations increase cognitive load, and stress really decreases your mental bandwidth, I mean, by quite a lot. And so the way you practiced for your interview over the weekend, very comfortably in front of your laptop, is not the environment in which you're going to be applying those programming skills. So you were practicing for programming, but you were not practicing for dealing with a stressful situation. So, the panic, anxiety can really, yes, limit your mental processing power, and it will really decrease problem-solving performance. And this thing about not recalling basic facts, that really does happen, like basic methods of well-known Java APIs, you just might have trouble accessing that. So there's a two-pronged solution. One is to offload tasks so you have more cognitive bandwidth available, and the second prong is to reduce anxiety. So when you reduce anxiety, the basic strategy is to habituate yourself to the trigger. And the best way would be to do a couple interviews and monitor your reactions, and then monitor how well you performed in the face of those reactions. And the idea is that after a few exposures, your stress and triggers will be reduced, and your ability to handle that emotional state will be increased. And you then replace the negative feedback loop that I described earlier with a virtuous feedback loop in which you know you can handle the trigger and still do the programming task. And that feedback loop in itself gives you a kind of knowledge which actually will reduce stress. Now, of course, in order to do this, you might have to burn a couple of interviews, and you might not want to do that. So the second best thing would be to simulate stand up in front of other people if possible, other developers, in front of a whiteboard, and talk through the interview scenario. So simulation would be an alternative to actually practicing with interviews. The third thing is that most developers want to get the answer right and they want to know things. And that leads to a problem. What do you do when you don't know something? And that will happen in an interview. So you need to devise a strategy of what to do when you don't know something. Like one strategy would be to try to relate it to something else that you do know. Or you could sort of say, well, I can't quite remember that method call right now or what parameters it takes, but I do know it does this, and in my code, I want to do this and this by using that thing. So at least you can relate it to something that you do know. The fourth thing is to reduce the importance of the interview, which is kind of a strange thing to say, but a lot of people invest a lot of emotional import into an interview, especially if it's with a marquee company, and we know what we're talking about there. So you actually have to reduce the importance of the interview. Try to make it a conversation, which is actually what they want. Mentally try to bridge the distance between you and the interviewer or you and the target company. Try to find something in which you can sort of not trick yourself, but maybe trick yourself into thinking that you belong there. So you reduce the importance of the interview, and try to bridge the distance between you and the interviewer. And the second prong is to reduce cognitive load. So practice the interview scenario with a realistic environment. Over-practice simple algorithmic coding exercises. And I mean like 5 times in a row. So you can do this without even thinking. Look at typical APIs like string, map, stuff like that, and just be able to work with them over and over until you get it without even thinking. And the reason why you over-practice is to free up cognitive load for problem solving. So you don't want to use your cognitive bandwidth trying to figure out what the correct call on this string is, but you want to reserve that ability for problem solving. And then find alternatives to whiteboarding. I think whiteboarding is very difficult. You're in an awkward physical position. You're writing in letters you're not used to. It actually adds a lot of cognitive load to an already stressed environment. So one thing you could do is bring large pieces of paper and some markers and perhaps do the coding interview on a desktop instead of the dreaded whiteboard. Some people are natural at this. I can't believe it when I see it, but to me it is just very, very difficult to just, the physical position and the marker, it says, unless you do it a lot, it adds to difficulties. And another way to divide the cognitive load is to first talk out the problem first and discuss in plain words a solution to the algorithm. So again, you don't want to start trying to solve the problem and code at the same time. You want to algorithmically in plain language, sort of come up with a solution, come up with the data structures you want to use, and then you can maybe get to coding. Okay, this is the coding interview itself. The coding interview is not about getting the problem right, although it is about that. What it really is it's a collaborative problem-solving exercise, and interviewers want to see that. So it's sort of like a conversation. What they also want to see is for you to take the initiative in driving. So think of it as a pair programming session, but you're sort of taking initiative and driving the problem-solving session. And the third thing is to really, when you're studying for the interview, really master the simple things rather than trying to cram advanced topics, because you're not going to remember them in an interview anyway. I mean, yeah, you're going to have to learn some new things, but really, I think if you try to master the simple things and be able to speak about them clearly with understanding, that comes across, and that's sort of what they want to see in the interview. So how to practice is, again, the best way is to create your own coding interview. Again, coding interviews test backwards thinking, which is, for example, a lot of people, when they study, they memorize the methods in a certain Java API. But an example of backwards thinking would be like this. If I had a character primitive, what are the different ways I could upcase that? And you could turn it into a string with one element in it. You could use the character API, which has a static method to upcase it. There's different ways, but the idea is it's sort of, there's an in-context thinking that interviews test, and you need to practice or study using that thinking. The fourth thing is a lot of people are using non-hinting cloud-based IDEs like CodeBunk. Practice that, because you can't believe how much you really depend on your IDE, and it's going to be completely different if you have a non-hinting IDE. You know, it really sort of shows you what you've been leaning on in the past. And practice whiteboarding separately, because you recall facts in the context in which you study them. So if you study code by typing, you're going to have a much more difficult time if you're being asked to write code. So actually practice with the non-hinting IDEs, and separately practice writing things down on paper. Another good thing is to really review the Java source and the comments. The comments in the Java source have these huge, almost book-like commentaries. And if you look at the source and you sort of drop to you sort of mention to the interviewer that you know something from the source, you browse the Java source, which is, that'll be some points for you. You can really learn some things. For example, the two-car array method actually makes a copy of the array rather than returning the underlying character sequence in a string. So that's something that you can plainly see in the Java source. So study the Java source. So this is actually what interviewers really want. They want to know how you solve the problem and how you interact with the interviewer in the problem-solving process. And the most important thing is to understand the problem. Repeat the problem, discuss sets of inputs and outputs. Just don't dive right into coding. it's really important to state and understand the problem. It's often more convenient to code the method signature, the API first, because that kind of reduces your nerves if you can do something simple. The third thing to do would be actually to do the corner cases. You know, whether you're going to, for example, in a lot of methods, in a lot of these problems, if you have a null or an empty collection coming into the method, you would throw an exception. So those corner cases, do those first, because they can help you relax and sort of get into the coding mood. The third thing that's important is to don't freeze. If you're stuck, you know, what they want to do is they want to test how you respond if you're stuck. So just don't freeze. You need to show that you're going to make progress even if you don't know something. So you're going to have to perhaps devise a strategy to somehow rely on something else that you know, and then explain how you would fill in the gap of what you don't know, and how you would then proceed to a solution. So they really don't want you to freeze. They want you to move the progress forward. Another thing they really like to look at is space complexity versus time complexity. In a lot of algorithms, if you store temporary results in a data structure, often a map, it makes the algorithm a lot easier. Like the Fibonacci algorithm is something like this. If you use a map to store your fib, if you have a map to store fib values, then your recursive algorithm is a lot more efficient. So another thing is they a lot of times ask you questions about resumes, or they'll ask you a simple question like, describe how a request goes to a server. What they're really asking is your ability to talk about technical subjects for about a minute or two. There's a lot of YouTube videos about this. They want you to sort of represent that you can know something in a managerial or almost architectural viewpoint, you know. So be able to talk about, you know, node or single page architectures, or how servers work, or something like that. So they want you to be able to discuss these topics convincingly or with understanding, rather than memorizing something. So prepare some 1 minute or 2 minute talks on a lot of on various subjects. Okay, I think this thing could help a lot. Almost everyone now has a GitHub where they store their code. Another thing that would help is to maybe have a live application on the cloud, or a landing page or something like that. That might be a way to take it to the next step. Any kind of personal projects that you have is very helpful, because they want to see that you can take an idea and translate into code, even if the project is irrelevant to the interview. So if you can show any sort of personal project, that's very helpful. So what that quote at the bottom means is a lot of people, when they go into an interview, they want this position, and they're going to demonstrate that they know this and this and this, and they can do these various things. That's actually a bad road to go down, because no matter how many things you know, the interviewer will list a dozen things that they would like you to know, and eventually you're going to run out. So the idea is to attract success rather than try to pursue it, and that relates to the personal project. So if you can present yourself as someone interested in programming, who can come up with their own projects, the discussion with the interviewer will be on a completely different level. They're not going to be bugging you about all the things you know or don't know. That conversation will be completely different. And again, that it'll serve to close the gap between you and the interviewer. I was speaking earlier about closing the gap or reducing the importance of the interview and discussing personal projects, programmer to programmer, instead of listing all the things you know, is a much better energy, and I think you'll be much more successful with that. I have on my GitHub an actual code example of an interview, and I think I'm probably going to be out of time for this. Okay. So the problem here is a typical one, is to take a list of integers and count their totals. Yes. This is actually a typical one, but what they do with it is the important thing. So you're doing a list of integers, and you're counting the totals, and it's obviously you're going to store this in a map. Like I said, the first stage is to state the problem, and it would be best to do the API first, do the method signature, and discuss with the interviewer valid and invalid inputs and outputs. So once you understand the problem, you're really halfway there. Second stage would be return type, various corner cases. So this is just an easy way to start programming. If you notice, this first example could use a little refactoring. There's some cut and paste code in there. And that's always good to mention, that you might refactor something. This is what it looks like. This is what it looks like with that cut and paste code taken out. I'll just run it right now. And let me run the first. I'll have to run the first one. So the first one threw an illegal argument exception because I had an empty array list, and then we have an array list with one member, and then an array list where you can get to count the totals. The key to this is I was asked to take my map and reduce the memory footprint. And I was thinking to myself, well, the only thing I was thinking to myself, which is not, the only way to reduce a memory footprint is to store the most frequent integer and the most frequent total. But I can't do that because the array is unordered. Had I said that, I would have gotten that. That's exactly what they wanted to know. But I was just thinking about it, and all of a sudden the interviewer started giving the answer to me before I could get anything out. And so always keep things moving forward and talk out loud, especially about your reasoning process. So the answer to the question is if I want to get rid of that map that I use to store running totals, the way, I can't do that because the array is unordered. But if it was ordered, then the only thing I need is this, which is to store the most frequent total, the most frequent integer, and then the current integer and current total. This is on GitHub and it all runs, so you can look at this. But the key is not so much getting the algorithm right, but the key really was the twist they threw in when they said, reduce the memory footprint of your data structure. That's a very typical sort of thing they do in interviews. They're stressing the exchange between space complexity and time complexity. So, are there any questions about all of this?
Yeah, I've got a question.
Yeah.
Is it common to? I've been through a lot of interviews and I've never had somebody ask me to do this.
I would say for more.
Could you repeat the question?
Yeah, is it common for someone to actually do this? And no, because the typical coding interview is a problem they looked up on HackerRank, and all they care about is that you get the algorithm or know the answer. This, though, is what you'll find at more, the more marquee type companies, and like we all know who they are. And obviously, I've been through a couple of those. But yes, they will ask that, and so they kind of go beyond algorithm memorization, and they get into stressing concepts in computer science and programming. So yeah, that's. Any other questions?
All right. Who's our next?
Yes. Okay. Thanks.